Welcome to 8-1 Perimeter and Area of Rectangles and Parallelograms. Some of the definitions that we're going to use in this lesson are perimeter and area. Perimeter is the distance around the outside of a figure. It's kind of like if you're looking at a table, you want to walk around this table, you're going to have to walk a certain distance around each side of it. So in order to find the perimeter, you have to add the lengths of all sides. So if you're looking for the perimeter of a table, you have to measure each side of the table, and then you have to add each of these dimensions together to find this perimeter. This is probably something that you've seen before. I want you to hit pause right now and find the perimeter of each of these figures. Please note that this figure is a parallelogram. Okay, so go ahead and hit pause now, try these examples, and we'll come back in a second. Good, hopefully you noticed that on the first example, it's a rectangle. So that means if one side is 6, the opposite side is also 6 centimeters. And likewise with the 4 and 4 centimeters. If we're going to find the perimeter, we have to take these and add them all together. So in order to do this, we're going to start at one side, and we're going to say 4 plus 6 is 10, plus another 4 is 14, plus another 6 gives us 20 centimeters. I'm going to say P equals 20 centimeters. Notice it's a distance, so you just have centimeters. You don't have centimeters squared here. Likewise, on the next problem, if these are parallel sides, then the opposite sides will be congruent. And again, we add them up. We get 5 plus 5 is 10, plus 7 is 17, plus another 7 is 24. And again, it's just feet. We just check and see what unit we're dealing with. All right, moving on to area. Area is if we were going to cover this figure with carpet, or if we were going to paint this shape. It's going to tell us how many little squares we can fit in the shape. In order to find the area of a rectangle or a parallelogram, we're going to take the base and we're going to multiply it by the height. Something I do want to point out, on the rectangle, this is very easy. Okay, base and height, we're only going to really have 2 dimensions here. On the parallelogram, our base is always one of the sides, and then our height tells us how high when it's perpendicular. So where there's a right angle, that height is what we're going to use. Okay, this side length right here doesn't really matter. It would if we were finding the perimeter. We're finding the area, so we only want the height. So if we look at these two figures really quick, finding the area, okay, if we mark how long each of these sides is. So here we have 1, 2, 3, 4, 5, 6 units. That's its length, or its base. And then we have 3 units on the side. We do 6 times 3. We say this is the area. So the area is 6 times 3, or 18 units. And we always have to put a square on there. Okay, that tells us we're dealing in square units. That is the area. A very similar situations going on over here on this diagram. This base is 5 units. Okay, and the height is 4 units. So we multiply those two together, and we say that our area is 20 units squared. Now if it gave us this in feet, if it gave us this in inches, we would say inches squared, feet squared. But since it doesn't give us any units, we just say units squared to show that. The last two examples involve a little bit of thinking and problem solving. If we're going to find the perimeter of each figure, okay, what we're going to do is we're just going to take each of these and add them together. Okay, if we were going to start, I would pick a starting point. I would say if I'm going to walk along here around the outside, what am I going to get? So I want you to hit pause really quick and go ahead and complete this one. So if I was going to start here and I'm going to go this way, I would say I'm going to walk 4, and then I'm going to add 3 because I have to go along this side, and then I have to go 1 here, then I have to go down another 3, and then I have to go across 5, up 2. I'm just going to go ahead and run this over here. So here I went up 2. I can see from this distance right here that this bottom is also 2. Plus 3, plus 2, plus another 2 going down, a 2 across, and a 3 going back up to my starting point. It is important that you get every side of this figure, because we're talking about the perimeter if we're walking around this figure. If we add all of these together, we end up getting 32 meters, and that is our perimeter. If we're going to find area of this figure, we have to break this figure into pieces. Okay, so instead of looking at the entire figure, we're going to say, let's just look at this portion, and then let's also look at this portion. Okay, this makes it just a little bit easier. We can find the area of each of these figures very easily. So our area of this figure right here, 3 times 2, we know it's length times width, so it's 6 meters squared. If we look at this rectangle down here, we know that this distance is 3, the length is 5, so this is 15 meters squared. And again here, our length of 4, our width of 3 gives us 12 meters squared. We have the areas of each of these. If we add together, we will get the area of the entire thing. So we add 15 and 6, we get 21 plus 12 is 33 meters squared. So we found the areas of each, and then we added each of these together to find our total area. I want you to try this last example on your own at home as a portion of the homework. We will talk about it in class, and you can check it. If you have any questions on this lesson, please visit the linked videos or Google area and perimeter of parallelograms or rectangles, whichever one is giving you the most difficulty.